So in this video, we are going to look at measurements, and we'll start with our basic uh, quadrilaterals. Now, in measurements, they normally ask you for some basic things. That will be perimeter, area, volume, the most, surface area. So those are the three things you must consider whenever you're doing measurements. So, and measurement is not necessarily about the formula, it's about a concept. So if you understand the concept, you don't have to go remembering a whole bunch of formulas. Alright, good. So first case we look at a square. Everybody knows what a square is. Right? All four corners are right angle. And all the sides are equal in length. It's called L. So if you were to find the perimeter, the distance around, that's what perimeter is, the distance around the shape, the enclosed shape. If you were to find the perimeter, then it will be 1, 2, 3, 4, add up 4 of the L's, 4L, and we'll get the distance around the shape. And that is 4 times the perimeter is 6 meters, the length is 6 meters, and that is equal to perimeter is 24 meters. I want to stop quickly to show you that perimeter is always in unit because it's considered just a straight line. An area is a space enclosed by a shape, whatever shape it is. So perimeter is the first dimension, just a straight line. Area is the second dimension, the space enclosed by the two sides. And volume is the third dimension. That will be the capacity of this shape to hold, of a solid to hold liquid or whatever. So area is always in unit. Perimeter is in unit. Area is always in unit square, and volume is in unit cube, 3D, 3D solid shapes. Okay, so the area is the space enclosed by the shape. So how do we get the space? There is length straight across here, and there's length straight across there. So the area of the square is L square, which is L times L. In this case, it will be 6 meters times 6 meters, which will give you 36 meters square. Area is always in meters square. So that's it for a square. Rectangle, no big difference, except that they don't have the same size. One side is longer than the other. This is called the length, this is called the width. So what is the concept? This this is a parallelogram, I must say. The rectangle is a parallelogram. It's a quadrilateral, but it's also a parallelogram. What is a parallelogram? What is the property of a parallelogram? Opposite sides are parallel and equal in length. So this side is equal to that side is equal to that side. So if you were to get the perimeter, the distance around, we would have to add 2 L's plus 2 W's. Simple as that. So if we add our length as 5.2 centimeters and our width as 3.9 centimeters, how do we get the perimeter? This will be 2 times the length, which is 2 times 5.2 centimeters, plus 2 times the width, 3.9 centimeters. And this gives you 10.4. Correct, 10.4 centimeters, plus this gives you 7.8 centimeters, which gives us 18.2 centimeters, and that's the length, that's the distance around the shape. So the area now, that will be the length by width, this side times this side, and covers everything in there, and that will be 5.2 centimeters times 3.9 centimeters, which gives us 20.28 centimeters square, because area is always in unit square. So what about a parallelogram? How do we find the area of a parallelogram or the perimeter? If you were given a parallelogram and you were asked to find the perimeter, this is the vertical height. They will have to give you this slant height here, there, and there. But in this case, we're only concerned with the area. So we understand what perimeter is now. We're dealing with area. Area is base times vertical height. If they had given you a slant height at 9 or whatever, you can't use that. We have to use the vertical height to find the area of a parallelogram. So if the base was 10 meters and the vertical height, the right angle, right, that was 8 meters, then the area of the parallelogram will be base times height, which is 10 meters times 8 meters, which is 80 meters square. So now we have a trapezium. Trapezium is a quadrilateral. It has 4 sides, but opposite sides are not parallel and equal in length, so it's different. How do we find the perimeter of a trapezium? You add the distance around. How do we find the area of a trapezium? Now you need to remember the statement, because the statement is the formula to find the area of a trapezium. It is, the area is equal to half the sum means to add, of the parallel sides times the vertical height. Half the sum of the parallel sides times the vertical height. The vertical height is the length always connected to a right angle. Trapezium can take this form or also this form. So let's find the area of this trapezium. So if the area is equal to half the sum of the parallel sides times the vertical height, it will be half the sum of the parallel sides. The parallel sides are 5 and 7. 5 centimeters plus 7 centimeters times the vertical height is 4 centimeters. This is half. When you add 5 and 7, you get 12 centimeters times 4 centimeters. Half of 12 is 6 centimeters times 4 centimeters. The area of the trapezium is 24 centimeters square. So what about triangles now? Done with quadrilaterals. How do you find the area of a triangle? Well, the area of a triangle, when it's a right angle triangle, or when there's a right angle indicating the vertical height, is half base times vertical height. And why is the formula of a area of a triangle half base times vertical height? This is why, because the triangle is half of a, could be half of a square, or it could be half of a rectangle. So because it's half of that shape, as you can see here, to calculate the area of a triangle, we do half base times vertical height. Alright, so this is, the base is 6, or the base could be 4. It's half of 6 centimeters times 4 centimeters, which is half of 6 is 3 centimeters times 4 centimeters. The answer is 12 centimeters square. So this is a right angle triangle. This is a different kind of triangle. This is called a scalene triangle. And the thing about the scalene triangle is that all the sides of a scalene triangle is different in length. All the angles are different, and all the sides are different in length. So when we have a triangle like this, there's no vertical height given, and we have all the sides of a triangle. To find the area of that triangle, we use an Aaron's formula. Right? where we add up all the sides, a plus b plus c, and that will give us the perimeter, and we divide it by 2, and it's called the S, the semi-perimeter. And then we put it into this formula. The area is equal to the root of S minus A, times S minus B, times S minus C. So, if we were to find the area of this triangle, with the lengths being 9, 7, and 6, we add up all the sides, 9 plus 7 plus 6 divided by 2. This will be 16, 22. 22 divided by 2, which is 11. So our semi-perimeter is 11. Alright, that is our S. And now we put that into this formula. So the area is equal to, S is the 11 minus A. If you notice, we're not using the cm. When we find the semi-perimeter, we know area is in unit square, so it will be in cm square. So we don't need to put that in there. So this is 11 minus 9 times 11 minus 7 times 11 minus 6 cm square. 11 minus 9 is 2, 11 minus 7 is 4, and 11 minus 6 is 5. So we multiply all of these, 11 times 2 times 4 times 5, and we'll get 440. And when we square root of 440, this will be cm square, and this will be 20.98 centimeters square. And that is the area of the triangle. Okay, so what if you're given a triangle like this? It is simple. As long as we're given a vertical height, like in this case, the vertical height is always connected to the right angle. We use this formula: half base, area is equal to half base times height. So it's half of, the base is 11.9 centimeters times the height is 7.5 centimeters. Half of 11.9 is 5.95 centimeters times 7.5 centimeters, and that is equal to 7.5, 44.6 centimeters square. Good. What if we are given a triangle like this? We have two sides of the triangle, and there's a given angle somewhere, and we have to find the area of this triangle. It's pretty simple. We use a different formula. We don't have any vertical height, and we don't have all three sides, so we can't use this Heron's formula. We can't use that formula because we don't have the vertical height. So we use this formula. Area is equal to half AB sine the angle. The area is equal to half AB sine the angle. What is A and what is B? One of these sides is A and B. So this is half times A, which is 80 meters, times B, 13 meters, times sine, the angle is 50 degrees. Half of 18 is 9. So 9 times 13 gives you 117 meters square, times sine of 50 is 0.766, and when we multiply the two, 117 times 0.766 Our answer is 89.62 meters square. So again, when you don't have a vertical height, when you don't have all the sides, but you're given two lengths and you're given an angle, we can use the formula to find the area of the triangle. We use the formula half AB. Let me write it better. Half AB sine theta. Now we go into circles. Now first we must identify the different parts of the circle and all that is done to circles. All the things that they can actually do for a circle. Okay, so this is the center of the circle. The line that is drawn from the center to the circumference is called a radius. The line that is drawn from one end of the circumference to the other end of the circumference is called the diameter or the diameter. And the diameter is the length of two radius. Right? I think it's pronounced radii. So the angle formed between here, right? The angle formed between here would use to be denote the, if we were to find the area of this little piece of pie here, piece of cake here, this would be called the minor sector, and all behind here will be called the major sector. Let me just give a little illustration again. Good. If we had a circle like this and the angle A was 90, this here, the area here, will be the minor, small sector, and the area behind here, this other big piece, will be the major sector. Now, what angle do we use for the major sector? We use the angle behind here. This is 270, because we know the angle at the point is 360. So again, we have the minor arc, the small arc, and behind here is the major arc. Now the area between a triangle, a chord, the area between a chord is a line that is drawn from one end to the other end of the circumference. This area between the chord and the circumference is called a segment. So in a circle, all the possible things you can actually do is to calculate the circumference, that is the distance around the circle, the arc length, that is piece of the distance around the circle, and we use the small angle for the minor arc length. We just want this piece, so we use the angle that is from the radius that is forming that little piece. They can actually, for the area of the circle, that is the space enclosed by the circle, they can ask you for the area of the sector. That area of the sector there, I spelled this wrong. Right. The area of the sector is the area enclosed by this little these two radii here, and this small piece here. Or they can ask you for the minor sector. So to get the area of the sector, we use the area of the circle. To get the arc length, we use the circumference, because the arc length is a piece of the circumference, we have to use the circumference to find the arc length, a fraction. The arc length is a fraction of the circumference, so we have to use the circumference to find the arc length. The sector is a fraction of the area of the entire circle, so we have to use the area of the entire circle to find the area of the sector. Alright, so let's solve a problem. So in this problem here, we're going to find all those things that they asked us to find on the other side. We're going to find the circumference, the distance around the circle, and that is 2 pi r or pi d. Pi in this case is 22/7, or it could be 3.142. We can use any, but in this case we're using 22/7. So this is 2 times 22 over 7 times the radius of the circle is 7 meters. 7 cancels with the 7, so we have 2 times 22, 1. 2 times 22 is 44, and that will be 44 meters. So the distance around the circle is 44 meters. If we were to use pi as 22 over 7, it would be 2 as 3.142. It would be 2 times 3.142 times 7 centimeters. Let's see what we get with that. Our answer on the calculator is 43.988 meters. This is very, very close to 44. If you were to round this to the nearest whole number, this would have had to have been 44. Okay, so let's go to the area now. Sorry, the arc length. The arc length is this little piece of the circumference, just this little piece here. We're not interested in the entire thing. We just want from there to there. So the arc length is equal to theta, because we want this piece of angle here, not the entire thing. We want this here. We want a fraction of the circumference. So it's theta over 360, that's our fraction of the circumference, times we want the circumference, so this is 2 pi r, right? Fraction. So this is 60 degrees divided by 360 degrees times, we already know the circumference is 44 meters. So it's a fraction of the entire thing, so 44 meters. 0.006. So this is 44 divided by 6. So the fraction of the circumference, or the arc length, is 7.3 meters. From here to there is 7.3 meters. Good. If you're asked to find the area now, area of the circle, it's pi r squared is the formula. Pi is again 22 over 7 times radius is 7 centimeters times 7 centimeters. R squared is r times r. So 7 goes with 7, 1, 1. So the area is 22 times 7. And we get 154 meters square. 154 meters square. Okay, so, and again, if you use the pi as 3.142, you'll get something very close to 154. You might get 153. Let me see it on the calculator. So on the calculator, you get 153.958. Again, very close to 154. Okay, so if we were to find now the area of the sector, this fraction, again, the fraction of the area of the entire circle, area of the minor sector, the small one, want the big one. So the area of sector, this is equal to theta over 360 times the area of the circle, which is pi r squared. So this is 60 degrees divided by 360 degrees. So this is finding the area of the minor sector. What if you were asked to find the area of the major sector, the big sector at the back there? You have to use the angle 300 over 360 because you're interested in the major sector, but we're only interested in the minor sector here. So this is times, we already know the area of the circle to be 154 meters. So this goes again 60 goes into 360 6 times, and that's is 154 meters divided by 6, which gives us 25.7 meters. square. So the area of this little piece here is 25.7 meters square. So last thing they can ask you to find, we said that the area of the segment, that is the area between the chord and the circumference, is a fraction of the area of the sector. But if you look at the sector consists of a triangle, and that little piece is area of the segment there. So how do we find the area of the sector? The area of the sector is the area of the segment, the small piece between there. The area of the segment is the area of the sector minus the area of the triangle. Right? And I do this because there's an angle there, and I know this is a radius, 7 centimeters. So the area of the area of segment is equal to sector, please write it out, minus triangle. Sector minus triangle. We already know the area of the sector is 25.7 meters square. So what is the area of the triangle? It's a triangle with an angle, so we have to use this formula, and you should do it here. I don't have space, that's what I'm doing up here. Half area of triangle is half AB sine theta. So half of 7 centimeters times 7 meters times sine 60 is 0.866. So it is half times 7 times 7 times 0.866, and that gives us 21.2. Right, so the area of the triangle is 21.2 meters square. 21.2 meters. So when you subtract the triangle, when you take away the triangle, all that is left is the segment. So that's why we say the area of the segment is the area of the sector minus the area of the triangle. When you subtract the area of the triangle, all that you have left is the segment. So 25.7 minus 21.2 leaves us with 4.5 meters square. Alright, so and that is the area of the segment. So one final thing is changing the subject of the formula. What if you were given the area of a circle? Let's say the area of the circle is, let's use back this number, 154 meters square. And they ask you to find the radius of the circle. They give you the area and ask you to find the radius. Can you do that? I guess so. The area of the circle, the formula for the area of a circle is pi r squared equal to 154 meters. This is the area of a circle. This is the formula. So if we want to find the radius, we know pi is, let's use pi as 3.142. So this is 3.142 r squared equal to 154 meters squared. So we'll have to take over that. R squared is equal to 154 meters squared divided by 3.142. So when you divide that, 154 divided by 3.142, you get R squared is equal to 49.01. 49, and r is equal to the root of 49 meters square. the root of 49 meters squared, which will give you 7 meters. So if they give you the area of a circle, or give you the circumference of the circle, the value of a circumference, let's say the circumference was 50 centimeters, and you asked to find the radius. Circumference is 2 pi r equal to 50 centimeters. Pi is 22/7, or that, so it's 2 times 3.142 times r equal to 50 cm. This is 6.28. Let's leave it at 6 point. Let's forget about this. 3.14. R is equal to 50 centimeters. So the R is equal to 50 centimeters divided by 6.28. Which is 7.96, which is like 8 centimeters. So if they give you the value of the radius, the value of the area, and they ask you to find the radius, the value of the area, the value of the circumference, and ask you to find the radius, you can do the change in the subject of the formula.